Hi there, I'm Jeff. I'm a product manager here at Cloud NC, and today I'm going to introduce you to the Cutting Parameters Explorer available in CAM Assist. So when you have a part in Fusion, like we have here, and you've generated the toolpaths in CAM Assist, you'll have access to the Cutting Parameters Explorer. This is available for certain tools here. And what cutting parameters are basically how we calculate feeds and speeds if they are not in the tool library. But you can also apply the Cutting Parameters Explorer to calculated toolpaths to adjust them depending on a number of variables. So let's open that up and see what that looks like. So just as a reminder, you have to be logged in to see the Cutting Parameters Explorer. So I'm just logging in on another screen here. Logging into my CAM Assist, so now that's logged in, it'll show up like that. If you're not logged in and you open up a file, sometimes you won't see that icon. So in the browser of calculated toolpaths, when I right click on the tool, this Cloud NC cutting parameters menu item, if it's not available, just make sure that you're logged into Cloud NC before you start, and then that'll show up. So this toolpath here is one of the roughing toolpaths, and you can see that here in the operation setting. So this is the Cutting Parameters UI. I'm just going to make this a little bit wider. So across the top here, we've got operation, material, machine, tool, and application. If I look at the operation, we'll see that we've got basically a duplication of the operations that we have there. It's got a notification on some of the operations that aren't supported. And I can see that I'm mapped to that first roughing operation. If I click on the material, right now I'm using a generic aluminum alloy. So that came from CAM Assist. I can open that up beside here, that selection there. In the Cutting Parameters UI, we actually have a lot more granularity in terms of the materials available, from our alloys in aluminum to steel, stainless, number of different types of stainless, as well as generic titanium. So we could change those parameters within the Cutting Parameters Explorer. We'll just keep that way it is. The machine. So again, this is coming from both our Fusion machine library and CAM Assist itself. The reason we have this machine properties drop down here in Cloud NC CAM Assist is in order to drive these values, these variables, into our cutting parameters algorithm. So we can see those reflected here. And the tool itself, so these are operations that are coming from Fusion 360 directly. And this is more for viewing. You can make some changes here, but we'll just leave that. And then the application is in relation to our work holding security. So again, if we had in CAM Assist that set up work holding security at a lower level, that would be reflected here as well. So in general, we can modify our feeds and speeds in the Cutting Parameters UI via this aggression slider, from preserving our tool life to increase productivity. So if I want to be more conservative, I'll drag it to the left, and you can see the values all update. If I want to be more aggressive in my cutting, I can go to the right, and it applies a lot of change to the parameters. These values aren't coming from a lookup table. They're coming from an actual calculation based on the physics and dynamics of the materials and the cutting geometry of the tooling. If I expand this out down here, you can see the fine tuning. And we can see right now that I'm in inch mode, and if I hover over the values, I get the millimeter setting. If I want to reverse that, I can come here to the settings and just change my unit system units. Basically, I can toggle between inch and metric. I'll keep it an inch. And so I can also use these parameters to make adjustments to my feeds and speeds by adjusting the maxes and the mins on each of these values, and that reflects on the whole model overall so that everything's dynamic. And I could change from the width of cut, depth of cut, the spindle speed, the feed rate. So if I want to be more conservative again, I can drag that down. I can decrease my chip load or ramp it up if I want to be more aggressive. Change my surface speed. That has iterational effects. And you can see when I make changes to these values, I can also revert them back by using these arrows. We have the tool deflection. So there's a mean calculation of tool deflection. I can change that slightly. And the work holding security, again, that's reflected here. Make those changes. Spindle power. So this would be something that would be more hard-coded depending on your machine, but you can make adjustments to it as well. The breakpoint, this is an indication of the radial force that's being applied to the tool. So essentially 100% here means the tool is going to break. So we're at a conservative level there. We can drag that if we want to be more aggressive. And our MRR, material removal rate, that's a hard calculation based on everything. And then our torque, again, that would be kind of mechanically defined by our machine. We can also see these values reflected. So each time I made a change here, this graphic would update. So we can scroll up to the top and see that. And I can also see these in heat maps. Some of these tools won't show much of a heat map, but this one you can see that we're in a green area there. So that's sort of ideal parameters in terms of our width of cut. And we can see heat maps for a number of different values. So if we wanted to look at surface roughness, for instance, see that reflected here, or surface speed. Let's go feed rate. That's a basic one. See that we're not in perfect ideal conditions, but we're in not too bad. So after we made those adjustments, what we can do is save that operation. And what that does is it takes us back into our cutting parameters here for the tool. And you can see that we've got a out-of-date toolpath, so we just have to regenerate that. And then those values that we applied in the Cutting Parameters Explorer will be calculated back into the toolpath in Fusion. So we can do that for each toolpath. Some of the tools don't have cutting parameters associated yet, but we're working on bringing those out. For instance, if I looked at face mills here, we don't support those yet. Now, if we looked at this again in cutting parameters, just waiting to make sure I'm logged in, and then all of those values that I applied before are in that fine tuning. They're all reflected there. You can also see before you save that you can see all of the values that will be changed. And we can change a number of variables for that toolpath. So it gives you a bit of freedom in terms of applying feeds and speeds to toolpaths. So let's take that as an example. If we look at another toolpath, just to show that it's not just working on one, let's look at this one here. So I'm going to regenerate it to start. Okay, so it's saying that the cycle time estimate from Fusion is 1 minute and 11 seconds. If I open up the cutting parameters, let's just take a coarse approach to this tool. We want it to be more conservative, and let's see how that's reflected in the cutting time. So I'm going to take that to a life, and just as a note, you can also view another slider here where if we want to make this a little different presentation using rubbing and chipping of the tool, we can drag those sliders down. We'll save that operation. And again, we have to regenerate it in Fusion. So we've increased the cycle time slightly because of those parameter changes. So that's reflected in the toolpath. All right. If you would like more information about cutting parameters, don't forget to check out the documentation page available through the drop-down menu under Cam Assist here. And stay tuned for more videos from the Cloud NC team about Cam Assist and cutting parameters. Thanks a lot.